So today we're going to be going over 6.1 graphing systems of equations, and it's going to be very important for you to follow along and listen closely to what I'm saying so you can crank out the homework. So first off, a system of equations is two equations that can be graphed on a number line. So for example, you could have a line that looks like this and a line that looks like that. There's your system of equations. Sometimes it asks for a solution, and what the solution is the point where they cross one another. So some words that you're going to need to know are consistent, independent, dependent, and inconsistent. Sorry about that. So a consistent line has at least one solution. So at least one solution. If it's independent, it must be consistent, but then have only one solution. So it has exactly one solution. And it's consistent and dependent if it has an infinite amount of solutions. So basically if the lines are exactly the same. And then that it is inconsistent if it has zero solutions. So if they never cross each other, they're inconsistent. So that means they have the same slope. Here's a little chart for you to be able to figure that out. So if there's exactly one solution, it looks like this, and it's consistent and independent. Infinite number of solutions, it's exactly the same line, consistent and dependent, and there's no solution when they are parallel to one another, and it's inconsistent. So here I've got some graphs graphed for you already. We've got our green line and our purple line. So if you look here, green and purple, they cross in one place. So going back and looking at my chart, that looks kind of like this one. So it is consistent and independent. And I'm just going to shorthand. Consistent and independent. Now we've got our green line and our red line. And oh look, their slopes are the same. When they have the same slope, they're never going to cross. So they have no solution and they're inconsistent. I want you to pause here and try to do these ones on your own and then compare with my examples. And you can always refer back to the chart that I have posted earlier, and you can make that on your own as well. So our blue line and our green line here cross at one place, so consistent and independent. Our purple line and our green line cross in exactly one place, so once again, consistent and independent. Here we have to graph it on our own, but we're still doing the same thing of figuring out what the systems are. And then we're going to add on figuring out what the solution is. So we just need to name that coordinate pair where they cross. So y equals x minus 2. So our y-intercept is -2. And we're going up by 1x each time. So we're going to cross at -2 and go up by 1 each time. I'm going to have to straighten out my line a little bit. But that's fine. It's a lot easier for you guys to graph on Excel. I'm kind of jealous. And here we have, I'm going to count by, never mind. Our y-intercept is 10, and we're going down by 3 each time. 4, 5, 6, 7. So it goes up 3 more over here to 10. Oops. And I'll extend it up that way. Sorry, this wasn't big enough. There. So there's our line here. Looking at it, it is consistent and independent. And our solution is right here where they cross. So I'm going to go and count and go, okay, it goes over 1, 2, 3. So our x-coordinate is 3. And our y-coordinate, we go up 1. So 1. So our coordinate pair is 3, 1. And that's the solution for that system of equations. Now here, our equations are written in standard form. When I graph, I really like them to be in slope-intercept form, so I'm just going to go ahead and change them into that right now. So 2x minus y equals negative 1. I'm going to move the 2x over, so I'm going to subtract it. So I'll end up with negative y equals negative 1 minus 2x. Now if I need to change the negative y into a positive y, I flip the symbols of everything. So we get y equals 1 plus 2x. And I'm going to do the same thing over here. So I have 4x minus 2y equals 6. I'm going to get rid of our 4x, so we're going to have negative 2y equals 6 minus 4x. I'm just going to write on this graph. Then we need y all by itself, so we're going to divide by negative 2. What you do to one thing, you have to do to everything. So we are going to have y equals 6 divided by negative 2 is negative 3. Negative 4 divided by negative 2 is positive 2x. And look at that there. We have a slope of 2 on both of our graphs. So going back up here, when they're parallel, when they have the same slope, there's no solution. They're never going to cross each other. So this here is no solution. Wow, I really cannot write, but you know what I'm saying. There is none. There's no solution. They're never going to cross one another. You can go ahead and try these two on your own and then check back, and you can move on to your assignment for the day. So these graphs, the answer here is there is one solution, and that solution would be 3, 1. And over here, it is infinite. They are the same lines. So there's an infinite number of solutions.